So, welcome everyone. Thanks for joining in. My name is George. I am a PhD candidate in computer science at University of North Texas. So, a little bit about myself is my research. I work with natural language processing and mostly with dialogue generation. And that's kind of the main reason why I wanted to make this tutorial, since I'm using GPT-2. I'm fairly familiar with it. I know doing text classification GPT-2 is not something expected for a lot of people, so I just found that interesting and I thought I'd share it. Before I begin, I already posted a link in the chat. Let me just try and post it again, so you guys can pick your like if you're familiar with NLP or what's kind of your level of knowledge. So then I know how to adjust this tutorial for you. And I have another screen here, so I might look up a few times. Okay, so just by looking at the polls, it looks like a fair amount number of you guys are pretty familiar with NLP, so that's good to know. As a disclaimer, so this is not your average tutorial on GPT-2. Like I said, I will not focus on the original purpose of GPT-2, which is text generation. In this tutorial, we'll use GPT-2 in a less conventional way, so for text classification. Okay, the agenda for today. So I'm going to do a small intro on like understanding natural language processing, a little bit about word embeddings, a little bit about text classification. Obviously, since a lot of you are already familiar with NLP, I'm just going to skim through those. Next, I'm going to do a small intro on the transformer model. Then I'm going to dive into GPT-2, talk about the architecture of the model, the inner workings, how it does predictions, and then how can we do classification with GPT-2. Next, we're going to dive into the coding session. And at the end, obviously, if you have any, I'm going to have some conclusions and then some ending slide. Okay, so if you Google NLP on Wikipedia, you obviously see this definition. So NLP is basically a field that overlaps a lot of subfields. It's a field of linguistics, computer science, and artificial intelligence. Concerned with interaction between computers and humans. As you already know, with NLP, we're basically trying to have the computer be capable of understanding human text and contents and so on. So understanding natural language processing. So I'm just going to glance to this example since a lot of you are familiar with this. So usually when you have a piece of text like this, for example, I love cats, cats are funny. You create a vocabulary based on text data, which the vocabulary is basically the unique words that appear in your text data. So you see I have, I love cats are funny, since cats appear twice, right? We just have it once in our vocabulary. And based on the vocabulary, we need to assign numbers, right, to these words, because if you want to do machine learning, if you want to do computing, we need to convert this into numbers, right? So we can assign an ID to each of these words in the vocabulary, right? So we can say I is 0, love is 1, cats 2, are 3, funny is 4. And this is a way of kind of encode our text into numbers. So then we can keep track of, what words we're trying to predict, or maybe what words are we trying to use, and basically encode them into numbers. The next, I'm going to skim through word embeddings. So if you go back to our vocabulary, right, if you look at love 1, cats 2, and funny 4, we try to plot these just using these numbers. So those are obviously features that we could use for words, for text data. But you can see that when we plot them, they don't have as much meaning as they should. So love, it's closer to cats than it is to funny, which maybe in some cases that's probably the case, but in a lot of cases probably love and funny should be closer than it is to cats. And next, what if we use, instead of one number, one fixed number, what if we use vectors? So we use two numbers in this case to represent the same words. If we try to plot them on the right, we can easily see that, we can start creating more meaning of these representations of words. And it's a better representation of using vectors than just using fixed numbers. And you can think of as the values in the vectors like features, right, for a word. And the more features we have, obviously, the better our representations are, obviously. And this is exactly what word embeddings are, right? They're a type of word representation that allows words with similar meaning to have a similar representation. So you can see that in this case, love and funny, they're closer together than they are with cats. And obviously, the more dimensions, so the more numbers we have in these vectors, the more features we have, the better the representation will be. And again, these will be really useful when we go into GPT-2. So what is text classification, right? Probably a lot of you know already. So it's just a task of assigning a set of predicted categories to text data. If you have a text classifier, you can easily organize, structure, categorize any kind of text, right? So if you have news articles, you want to categorize them by topics. You can easily do a text classifier. If you have like support tickets, for example, you can organize them by urgency. If you have movie reviews and you want to see the sentiment, right, if it's positive or negative, that's something you can do with a text classifier, basically. And regarding the movie reviews, so this would be kind of a diagram, right? So you have on your left side your movie reviews data, which is your input text. In the middle, you have the machine learning model, right? Which, if you translate text into numbers or vectors or features, you can obviously use any machine learning model, right? Because that's what machine learning models use, are basically numbers, features. And next is the predictions. So on the right side, we have our labels. It predicts positive or negative. Next, I'm gonna talk about the transformer. So I know probably, so since a lot of you are familiar with NLP, you all heard about transformers. Like, it's crazy right now. Everybody's publishing books, tutorials, articles. You can find a lot of them online. And almost everybody is using transformers in NLP. Even in images, they start using it. So NLP is basically a deep neural network architecture for transforming one sequence into another one. So that's why they call transformer, right? Because they're transforming one sequence into another. And it uses two parts. So it has an encoder and a decoder side. More on this later. It was first introduced by Google in 2017. So that's a while ago. And in the paper, attention is all you need. So I definitely recommend you guys check that paper. And the transformers are based solely on attention mechanisms, and more of that later. And it brought probably like the biggest leap forward in the past 5 years, and one of the biggest leaps forward in the history of the search engines. This is what Google said. So it's definitely a huge breakthrough. Like, transformers are a huge breakthrough in natural language processing. And actually, when Google started using Bert, which is an encoder transformer model, it gained like huge performance and huge gain in this. So it's definitely something to consider and something really important. So like I mentioned before, the transformer is basically transforming one sequence into another. It has the encoder. So you see on the schematics, we have the encoder on the left side and decoder on the right side. The encoder is the part where you feed in the input text data, and the decoder is the part that outputs other text data or other formats of the input. So like I mentioned, you can transform, basically. You can transform an article to a summary, for example, or it can translate English to another language, and so on. And that's the whole idea of, okay, transferring one sequence into another one. And as I mentioned, it's solely based on attention mechanism. And what that means is basically it's able to assign different weights to the words in your sequence. So it's able to probably focus on different words in the context, uh, depending on how that context looks like. I'm not going to cover attention a lot in this one. This is everything I'm going to cover since I believe it's a really, really complex topic and would probably require a whole tutorial by itself. But I definitely recommend checking out the Illustrator Transformer from Jay Alomar. He's like a great guy. His content is awesome, really visual, really easy to follow. So if you want to know more about attention, then that's the place to go. All right. So next, I'm gonna talk a little bit about GPT-2. If you Google GPT-2 on Wikipedia, GPT-2 is a generative pre-trained transformer. Uh, it's an open source artificial intelligence. It was created by OpenAI in 2019, so roughly 2 years ago. And in the definition, it says clearly that GPT-2 is able to translate text, answer questions, summarize passages, and generate text output. Um, and it also says, like, on a level that, well, sometimes indistinguishable from humans, uh, can become repetitive or nonsensical when generating long passages. So this is where people really afraid that AI is going to take over. It really sounds like a human, but if you use it a few times, you kind of quickly realize that's obviously not the case. Okay, so next I'm going to talk about the architecture of GPT-2. So going back to the transformer architecture, we have the encoder and decoder components. With GPT-2, we're only using the decoder side. So it's the architecture is just the decoder side of the regular transformer architecture. And what they did, what OpenAI did with GPT-2 is say, okay, we're going to grab this decoder architecture and we're just going to stack it on top of each other. And that's what basically, those are the components of GPT-2. And there are a lot of variations of GPT-2 depending on the number of decoder blocks. So you have like a small, medium, large, or extra large, and with stacking more and more decoder blocks, it also increases the model dimensionality. So the model dimensionality, that means how many tokens, so how many words can you feed into the model. With a small model, it can feed 768 words. But then with the extra large model, you can feed 1600. So that's kind of the architecture. Next, I'm gonna talk more about the inner workings. So this is where probably a lot of the audience today probably get more in-depth information about GPT-2. So this is a diagram that I created. First of all, I created for me because I wanted to see, like, hey, what's exactly happening behind GPT-2, right? I want to see what are the embeddings, where are the embeddings going, what's the flow through the model. So I kind of created this really huge diagram, which I know I'm going to try to explain it like in really high overview. So bear with me. I'm sure this might not make sense to you at first, but it's something that I'm just going to glance over it. So then you can go back and check it in more details. Like this diagram, you can spend hours and hours on it. So let me zoom in a little bit. Yes. Yeah, obviously I was going to zoom. I don't want to ruin your guys' vision. Okay, I hope this is zoomed enough. Don't want to be too zoomed or too zoom out. On the right side, you have the notations, right? So how do I represent, when you're adding tensors, which are basically matrices. you want to transpose them or do dot product, and so on. You kind of know what operations are going on with those embeddings, with those word embeddings. So going from bottom to top, so bottom is the input to the model. We have our sentence, which I mentioned previously. It says, "I love cats, they are funny." So we have this text data, right? That's our input. The first thing we need to do, as I mentioned with the vocabulary, is we need to assign ID numbers, right, to each of the words in this input sequence. So in order to do that, we have this what's called tokenizer that's specially designed for GPT-2. GPT-2 has around 50,000 words in its vocabulary. So that means that the list that you saw with 0, 1, 2, well, it has like 50,000 of words in that vocabulary. And what this does is basically, okay, I feed a text, "I love cats, they're funny," and the tokenizer, it's gonna recognize words in that sequence, and it's gonna say these are the list of IDs of those numbers, of those words. So on the left side, we see the input IDs. So you have 40, 1,842, 11,875. So these are the word IDs that GPT-2 recognizes, right? So this is how we need to translate the text into numbers. So then we can feed those numbers into GPT-2. So we feed in the text to GPT tokenizer. This outputs the tokens IDs. And by the way, when I say tokens and words, I kind of mean the same thing. Obviously, a lot more of you guys that are specialized in this, the finer details in that. So we feed those token IDs to the GPT-2. So when you see the I guess purplish or blue huge block here, that's when it enters the model. Right. First thing it does, it goes to the GPT-2 embedding block, and it basically grabs those IDs and then it looks up for those embeddings, and then it creates this embedding sequence. So I don't know if you guys can clearly see, like, we have 8 words in the input sequence that the tokenizer was able to process. And we're basically going from 8 tokens to 8 768 word embeddings. Oh, and I have a question in the chat. So does an input have to be in English language and Roman scripts? Can it process other languages or scripts? That's a really good question. Usually for English, we have GPT-2 that can handle English language only. And if you have Russian, then if you're dealing with Russian language, you have GPT-2 that's trained to recognize Russian language. So to answer your question, like for this model that I'm using, yes, it needs to be English. You can feed it other languages, but it will look at it as being English. So it might not make a lot of sense. But there are other models that are specifically trained for other languages. Really good question, thank you. So we have our input that's going to the embedding block, and the embedding block basically creates the first set of embeddings for our input sequence, from our input sequence. Next, we go into this huge block, which is our attention block. So this is where all the self-attention operations are happening. You have the query key and values. So this is where you can, later on, you can go in and see what's actually happening to each of those embeddings and how is the self-attention, what are the operations that GPT does for self-attention. Okay, and as you can see, between each blocks, we have a consistency of the size. So one block is feeding 768 word embeddings, and the other block is outputting 768 word embeddings. And what basically does is, at each layer, the embeddings get more and more refined, if you will, and more adjusted. So then it has greater and greater context information. So it goes to the attention block, right? it has a residual connection. So you see the plus sign here. And if you're asking me like why are they using this, to be honest, I don't think they know either why. They just tried it, whatever seems reasonable. They just try this architecture and they say, hey, it works, let's just use it, right? So it has some bunch of convolution layers, activation, normalization, dropout, and so on. We have the MLP block, which is the multi-layer perceptron block. Then again, a residual connection. And you can see the green one here, that's where the GPT-2 block actually finishes. And we have 12 of these blocks for the smaller version of GPT-2. And then at the end, the layer normalization, and that's basically our whole GPT-2 model. And then obviously we're doing, it's designed to do text generation. So we need a language model head layer. And it basically grabs those embeddings and then predict over the 50,000 vocabulary what words should follow. I see a few questions in the chat. So can we use the GPT-2 for multi-label classification? Yes, the answer is yes. What you have to take from this is that GPT-2 is going to output features right from your text. And you can take those features and just treat it as what they are, as features. And then you can do classification, you can do multi-class classification, you can do generation, you can do anything you want with those features. And another question was, are these deep architectures usually the result of extensive trial and error, or do scientists work on hypotheses when constructing them? I wish I knew that answer. I'll probably know that answer if I work with OpenAI and see like their techniques on this. But usually, me as a researcher, we always have a hypothesis, and we work from that hypothesis and try to prove that hypothesis. So I assume maybe they have the same approach. And I also think that there's a lot of trial and error, right? You always come up with new ideas like, hey, can we add another normalization layer, see what happens? If the results are fine, I think it's a little bit of both. It's also work on a hypothesis, but also do a lot of trial and error scenario. So this is in a nutshell, what the inner workings of GPT-2 look like. Again, I know this is a lot of information, like this diagram is super complex. But now you kind of have an idea of what is the purpose of this diagram and how to read it. And next time you can go through it, it's going to be a lot clearer. So, and I'm also going to share the slides and everything with that. Okay, so we covered inner workings. Next, I want to talk about predictions. So I also keep getting a few questions in the chat. I'm going to try to kind of not interrupt too much the flow and try to get back to your question. So if you post a question and don't answer it, just bear with me. Okay, so regarding the prediction, so going back on the definition of GPT-2 from Wikipedia, it says it translates text, answers questions, summarizes passages, and generates text. Now let's see how it actually makes those predictions, right? Now, since you've already seen the inner workings, what I'm showing you right now should be a little bit easier to digest, right? So again, going from the bottom to top, so bottom is the input to the model. So we're passing the text, for example, a robot must. And we have our word sequence, right? We have a, robot, and must. That's our input here at the bottom. And we feed that to GPT-2, right? So like I mentioned, the inner workings, we translate those words and IDs. We feed it to GPT-2, and then GPT-2 does its magic with the word embeddings, and then outputs those 768 word embeddings for each word. And one thing that's great about GPT-2 is that it can run it runs everything in parallel. So every word is running in parallel, and that's the beauty of it. So the GPT will output word embeddings, for each of the words in the input, and we usually take the embedding from uh, the last word, and we use that to predict the next word. So we take that embedding and feed it to a classification layer, like I mentioned in the previous inner workings diagram, and the classification will predict the word obey from the GPT-2 vocabulary. Right? So this is kind of a nutshell what's happening behind the scenes. And the thing is, like I mentioned before, so GPT-2 does translate text, answers questions, summaries. So all of this is basically done with text generation, right? When you translate text, you generate one word at a time in that new language. When you answer questions, right, you have to generate that answer, right? Generate one word at a time. When you're summarizing passages, again, you're going to summarize, you're going to generate one word at a time. So what I'm showing you here, the prediction, it basically it's kind of general uh, true about like any of those tasks, like summary, translation, and so on. So let's go through another example, right? So of the prediction. Now we predicted obey, right? And now our new text, it's a robot must obey. So again, going from bottom to top, bottom is our input. We have a robot must obey. So those are each of the words. Again, we feed them to GPT-2. Same process is repeated. Uh, Again, we're getting those 768 word embeddings. Um, and we use the last word embedding to generate the next word that should follow, which is orders. And basically, that's how GPT predicts the next word. And probably you might ask, like, why are we using the last word embedding? Or does it matter which word embedding are we using to do our classification? And the answer for GPT-2 is yes. Remember the self-attention that was assigning different weights? Well, the last word embedding contains also information about its context, right? So the last word embedding contains the most information about our input sequence. And that is why the reason why we're using that last word embedding, because it contains the most information. It contains enough information for GPT-2 to predict what's the best next word to predict. Um, and so that's the reason why we're using uh, the last one. Let me. So this is kind of iterating over everything I already mentioned. So this is how GPT-2 is able to translate text, answer questions, summaries, and so on. It's all just text generation, basically. Um, and before I jump into the text classification part, let me just take a few questions. Um, so I have a question regarding time series. So do you think it makes sense to use it for this kind of data? And do you know if this is being used in information to be documented? So, uh, so you're having a question about time series. It's so I'm trying to think. So I'm not sure if you're referring to kind of strictly time series data, so like any type of time series data, or just like text data. So usually like text data and the way it's fed to the model, it's uh, it's a it's an order dependent, so it's similar to I guess the time series data. So like the order of the words matter. So in the same case, okay, so you did mention like strictly time series numeric data, and the answer is yes. I actually seen people using probably not GPT-2, but using a transformer model, for time series data. If I remember right, I think I even saw somebody I was doing stock prediction using transformer model. And again, you can use it on any time series data because the way text is generated or the way we deal with text is that the context matters and the order of words matter. So if you use the same algorithms we use to generate text into purely time series numeric data, it's basically the same relationship, right? The last occurring scenario basically depends on previously occurring scenarios. Like any documentation to start with, it's kind of hard because that's something that people took a tool that was designed for something and they use it for something else. So it's not clearly on my mind. Like there's not any clear documentation for that. But try like Googling, stock prediction using transformer or stuff like that, and that should point you to the right direction. Very good question. Another question is, does it have any data limitation for the algorithm to work with? The answer is we kind of need to limit. Like you've probably seen, there's already some limitations for this model in the sense that how much text data can we feed to it at once. Like I showed you previously, we have, I think it was 768 tokens, maximum number of tokens we can feed to the small version of GPT-2, all the way to 1,600 words. So there is that limitation of how much data can we feed in at once. But then if you go at the limitation, okay, how much data does it need to train or can it handle? It can just, so the way they figure out with GPT-2 is that the more data we feed to the model, the better it performs. So answering your question from a data perspective, it doesn't have any limitation on how much data can you train it. Like it does get better and better with more data. That's why GPT-3 is basically GPT-2 on steroids. So it has just more decoder layers and more neurons and so on. And somebody else, can you demonstrate how GPT-2 works with real examples? So the purpose of this tutorial is not to show you how GPT-2 generates text, but I am going to show you the code to use GPT-2 for text classification. And does this simulate the markup process? Yes. Are there bots using GPT-2? I'm sure they are. I don't know how many bots, but I think it's. All right, I'm going to take a break from the questions. So going back to the prediction. So I'm going to go over the simple text classification part. I kind of went over how it generates text just to kind of give like an overview of how GPT-2 works and then how can we change that to work with text classification. I'm not intended to show you, hey, how well GPT-2 does on text classification, right? Because that's not the purpose here. All right, so let's go to classification. So now we'll use GPT-2 to perform text classification, right? So going back to our previous diagram that I showed you with the movie reviews. So we have our movie reviews on the left side, which is our input text. And now we're going to use GPT-2 as our machine learning model. We're feeding the text data, as you've seen previously with the ID numbers and tokens and so on. And then we need to train or fine tune the GPT-2 to predict either positive or negative labels. So GPT-2 out of the box is trained to generate text. But now we want to make it do classification. So we obviously need to do some training on it and say, hey, I don't care about generating text. I care about the predictions on these labels. So we need to do some training, or what they call it, fine tuning, since we're using a pre-trained model to do a different task than we're supposed to. So we're fine tuning on that specific task. So we'll classify movie review as being either positive or negative sentiment. So let's look at a positive review, right? So again, from bottom to top, bottom is our input. We have the text. The movie was great. So we split that into words. We have the movie was and great. We feed that to the GPT-2 model. Again, same behavior as we did with generation. GPT-2 is going to output word embeddings for each of those tokens, each of those words. And again, we're grabbing the last word embedding because that's the one that has the highest information of the input sequence. And we feed it to a classification layer. But instead of saying, hey, out of the 50,000 word vocabulary, which word should this sequence follow? Instead of doing that, we're saying, okay, what should be the sentiment that that represents this input sequence, right? So you can see how easy it is to change GPT-2 to do text classification. It's as easy as saying, hey, I'm just going to change the last layer in GPT-2 that does a prediction that predicts the next word to a layer that just predicts what's the sentiment. So instead of having 50,000 labels that I need to predict from, I'm just going to predict from 2 labels, either negative or positive. So that's the part where I want to bring you with this whole information. This is the only thing that we're doing different with GPT-2. It's really straightforward, nothing crazy. We're just modifying the last layer. And you've probably seen with your previous research or experiments or whatever experience you guys have using pre-trained models, especially in images, you cut off the last layer and then add whatever layer you need to use for your data, right? So now if you want to look at a negative movie review, again, starting from the bottom to top, we have the movie was awful. Obviously, it's a negative review. Again, feed it to GPT-2. GPT-2 outputs, does its magic, and outputs a series of embeddings. Again, we're looking at the last embedding. And then we feed that to our classification layer and saying, hey, this was a negative. And again, out of the box, GPT-2 obviously is not trained to recognize, to predict sentiments. It's trained to predict words. So that's why we need to do some training, which will mostly affect the last layer that does the either negative or positive classification. So next will be the coding session. Before I jump into the coding session, I want to take a few more questions. So let me see. So one question was, how could we use GPT-2 for text summarization? Again, that's something unfortunately I don't have the time to cover in this tutorial. But there's definitely a lot of material out there that you can check out. And guys, again, if you are asking questions that are probably not strictly related to this tutorial, to this topic, and I mean text classification, feel free to email me. I'm pretty fairly responsive. Email me with questions that are probably not related to this tutorial. I'll be more than happy to reply and kind of point you to the right direction. And I'll share my email at the end of the presentation, so stay tuned. Let me see. Can you compare GPT-2 with the ULM fit in terms of text classification? Unfortunately, no. I mean, that's not something that I will do in this tutorial, but that's something quite interesting, like comparing different models like this. To be honest, I'm not fully familiar with ULM fit. And then you're asking GPT-2 would require more training data than ULM fit. So again, to be honest, I'm not familiar with ULM fit. I'll probably need to take this offline. Regarding how much more training does it need to take for text classification, the answer would be probably somewhere around like a few epochs, depending on how big your data is. Usually when you fine tune a transformer model, for example, the authors of Bert say that probably in 2 or 3 epochs should be enough to fine tune the model on a different task. Okay. Another question, great question. Could you provide some details on the layer of the embedding sequence? Why is the last embedding only used for classification? So I'm going to iterate a little bit over what I already said. So the reason why we're grabbing the last embedding when we do the prediction is because, like I mentioned before, we're using the, let me go back here. So GPT-2 as any transformer model is using attention mechanism. So that means it assigns weights to different words in its context. So the reason why we're using the last token is because that's the one that contains the most information uh, for that sequence. So go here. So if we would use the first embedding to do the prediction, then we don't have any information about the next tokens, right? But if we take the last embedding, so the last embedding from the last token on the far right, that one contains information about must, about robot, about A, so it has all that information, and then it could do a better prediction than just using the first one or any other of the other word embeddings. So I hope that clarifies. That's a really good question, really important question, because that's the core of this tutorial of all this information that I'm presenting to you, is that we're using the last embedding uh, in the sequence to do our prediction. And the reason is because that's the one that contains the most information. So thanks for the question. Yeah, and glad I could clarify. Okay, so let me go into our coding session. And before our coding session, before I'm going to start our coding session, I want to give you guys a quick link. Again, another poll that would really appreciate if you guys can give some feedback on how is this tutorial going so far. Am I providing you new information? Is this something you already know? Should I go into greater details on parts of this? So the more of you that answer this poll, the better I can provide information to you guys. So I encourage all of you to kind of access the link that I just gave you in the chat and just put your responses there. And I'm gonna take, so I'm gonna talk about the coding session, and I'm gonna go back to the questions in the chat. So on the coding session, I'm actually using a tutorial that I already published, I think it was last year. So the code and the documentation for this code, I wrote it like a few months ago. I'm just gonna reiterate over it. You can open it in Colab, you can see it in GitHub, you can download it locally, you can check it on Medium, I have it posted there, and you can also check it on my personal website. And this is a complete tutorial on how to use GPT-2 for text classification. And as a disclaimer, the format of all my tutorial notebooks are fairly similar to each other. And I do this in order to kind of keep it consistent and have the reader be more familiar with my format. And again, this notebook is used to fine-tune GPT-2 for text classification, and I'm going to use the Hugging Face Transformers library on a custom data set, which will actually be the movie. Here's somebody say that no sound. Can you guys hear me? Okay, so it's okay. Okay, thank you. Just making sure if it's just, okay, great. So let me post the link again from the poll. Again, please, let me give it to everyone. So again, I encourage you to follow the link that I just sent again in the chat, and just give me a small feedback of how this tutorial is going, so I can probably adjust and kind of give better experience. All right, so let's go into the code, right? Because that's what everybody's been waiting for, right? Just show me the code. So let's go into the code. I ran this a while ago, so let's reconnect this. So if you click the open in Colab, And again, this is all going to be shared, so you guys can try this on your own. Actually, let me just um, copy link address. You can just access it right now. The link is there. I just posted the link in the chat for the notebook. Okay, so and by the way, guys, thanks so much for your feedback. It looks like most of you had a pretty easy time following my tutorial. So I really appreciate that. All right, so usually I recommend following this notebook using the table of content because there's a lot of content and code here. So I recommend using this to follow. So again, these are parts that I already discussed. How does how are we using GPT to do text classification? What should I know for this notebook? So since I'm using Pytorch, right? If you have any knowledge of Pytorch, that's really useful. Obviously, Python. Knowing a little bit about transformer libraries helps too. Again, it's not a deal breaker. If you don't know any of this, you can easily catch up to speed. There's a lot of material out there to learn, a lot of videos. How to use this notebook. So every code that I post out there to people, I code it with reusability in mind. So I try to make it as reusable as possible. So then you can plug in your own data or your own research or whatever you want to try this code on, and it should be fairly easy to do that. And if not, I'm kind of guy that if I deliver a product, I also expect to provide support for that product. So the code that I'm showing here is my product. So again, if you have questions, feel free to reach out, and I'll try my best to help you. The data set that I'm going to use for this classification is the movie review data set. So it's called the large movie review data set. Um, and this is from the Stanford website. So it basically has 25,000 highly polar movie reviews for training and 25,000 for testing. And they're labeled as being either positive or negative. And I have a link here for more details on the data set. All right, so now let's jump into the code. So let me see. So I see that you guys are trying to find out more details. So I'm kind of by looking at the poll results, it looks like a lot of you want more details, and that's a great feedback. I'll try to give more details. And if there's something that you wanted to be covered, yeah, feel free to answer the question, put a question in the chat. All right, so following the notebook, our downloads cell. So this is just going to download the movie review data set, and it's going to unzip it. And again, guys, this is all commented, and I feel like it's pretty decent documented, so it should be fairly easy to follow. Next, we have the installs. So in the install, we wanna do well, obviously want to install transformers libraries. That's the most important. I also have the ML things, which this is not critical. This is just a library that I created myself, so I can do easier plots of my training process and things like that, like related to my machine learning experiments. And again, you can also check that out, where I usually try to put snippets of codes that I use a lot in my day-to-day research. So that's installs. In our imports, obviously that's where I'm going to import all the libraries I'm going to use for this notebook. And I'm also going to declare some parameters for this notebook. I've seen some questions in the chat regarding like batch size or things like that. So I set the seed. I always like to set the seed to a fixed value, so then you have reversibility. Obviously, in research, in a lot of cases, probably you should not be using the same seed, right? Epochs, obviously, is the number of training epochs that I'm going to use. Usually the authors of Bert, sorry, recommend between 2 and 4. I believe I'm using 4 in this tutorial. The batch size, so batch size obviously is the number of examples that we can feed in at once to the model. Since this is a big model, you might get like out of memory errors with if you're using a GPU. So that's the one thing you need to change. You need to play around with, kind of see which batch size does not give you any errors. I usually try with 10. You can do 32. If you keep getting errors, you might have to lower your batch size all the way to 1, which that's normal. Don't be scared or shocked. These are really big models. Device, so that I'm using that to kind of switch between GPU or CPU if GPU is not found. The model name is basically we're going to use GPT-2. Here's where you can use different versions of GPT-2 or maybe different models. So I saw in the questions that some people want to use different models. This is where you can put a different model name. Labels IDs, again, like with any classification, we have our labels and then their IDs. So I'm using positive and negative. Again, I'm going to assign 0 to negative and 1 to positive. And then the number of labels is just how many labels I'm doing classification. I see some of you are drawing, so I would really appreciate if you guys probably don't do that. All right. So on the imports, so like I put the set seed to 1 to 3. I'm going to do 4 epochs train. Batch size, I'm going to use is 32. Another parameter that I have, it's called max length. And what I mean by this is that I'm just going to use the first 60 words in my movie review, in my example, right? So if I have a movie review that has 200 words, I'm just going to look at the first 60 words. And the reason why I'm doing that is that it speeds up training by a lot. And a lot of times you don't even need to use the whole text sequence, right? So the model can do a pretty good job just by looking at the first 60 or first 100 words. This is, again, something that you can play around with and test it out yourself. Device, again, it would look for CUDA. It would look if you have a GPU available. If not, it will switch to CPU automatically. The model name is GPT-2. So if you want to use GPT-2 large or extra large, this is where you would put what model do you want to use. Again, like I mentioned, the label IDs. So you have 0 for negative and 1 for positive. Those are just the, I guess, the associations that I made for these labels. And number of labels, obviously, is going to be 2 because we only have 2 labels. Right? Next, I'm going to go over the helper functions. So the helper functions, so the way I structured this is I like to put all the helper functions in one place. So then it makes the rest of the code easier to follow, in my opinion. And this is where I put all the functions or classes or whatever that I'm going to use throughout this notebook. The first class that I'm going to create is the movie review dataset, which is basically a Pytorch dataset class. And that is where I'm actually reading the dataset and the labels. So if you're familiar with Pytorch and Pytorch dataset, then this is going to be a breeze for you. As an overview or in a nutshell, the Python dataset class needs to have 3 components. The init part, as with any Python class, where you read the dataset and the text and the labels and so on. The len is where you need to return the number of examples you have in the dataset. And then the get item is the one that basically returns an example from the dataset. So if I say get item 3, it's going to go in my data set and return the third example from my data set. So if you don't know a lot, if you're not too familiar with Pytorch data set, these are the three main components. Next, I have what's called a collator. So those are basically um, parts where you can basically, excuse me. Sorry about that. Let me just get some water. Okay, I apologize for that. So the collator is basically a part where you kind of modify the data, right, as you go. So it's a function that you can apply for each example in your data set. And again, this one has two components. You could probably read more from this. It basically, the collator is basically the part that takes the text data and converts it into those word IDs, into those token IDs. So it's using the model tokenizer, basically. Next, we have the train function, which, like the name suggested, it's the function that we're going to use to train our model. And this is fairly standard in a Pytorch model. If you're familiar with Pytorch, this is fairly standard when you're training or fine-tuning a Pytorch model. It basically goes through each batch, each training example, and does the back propagation and so on. Next, we have the validation validation function, and as the name suggested, this one is fairly similar to train, but you're only doing inference, right? You're only doing predictions. So now going to the code and kind of iterate a little bit over it. Again, you probably see that this is has a lot of comments, so it should be pretty easy to follow what I'm doing here. Again, the movie review dataset is the Pytorch dataset class. We have the init here where we basically load the whole dataset and parse all the examples and the labels. Next, we have the length part of the Pytorch dataset where it just returns the number of examples. And the get item is the one that basically returns the example, a certain example in our dataset. So we'll just give it the index and it will return our example from the dataset. All right, the collator is basically, so it's using the tokenizer, the model's tokenizer, and it figures out like the max sequence length and the label encoder. And what this does is basically applying the tokenizer to the text data. So if you look at the call function here, you can see that we have our text and our label, and we're just calling the label encoder. So it gives a 0, 1 to positive or negative. And then we also have the tokenizer that basically takes the whole text as an input and returns those token IDs, so those number IDs. And then just returns the inputs. So the collator is the one that basically prepares the input so then you can use it into the model, right? It basically creates the input in the right format for the model to recognize it. Next, we have the train function. The train, as I mentioned previously, it's using the model to kind of train it. So it goes into each batch in our data loader. It grabs that batch and it loads it. When it says to device, that means it moves the batch to device. So if you're on a GPU, you need to move that batch on a GPU, obviously. The true labels here, I'm just keeping track later to see how well the training is doing. So I'm just keeping track of the true labels and the predicted labels in the training process. So then I can see those training graphs, see how well the training evolves. Model.0, so if you're familiar with Pytorch, you have to set all the gradients to 0 before you do a forward pass. Outputs, this is where the forward pass happens to the model. So this is where you take the input text. Actually, let me do it like this. This is where you take the input text and then feed it to the model and get the output. Which the output is basically our logits, so our predictions, our probability on those two labels. Then we have our loss, obviously, and we have to do a back propagation. And it's also doing a clip on gradient, so we don't have exploding gradients. Then we're doing a step towards optimization. So that's what we call the optimizer. The scheduler again. So these are components, basic components when you use Pytorch to train a model. So if you're really familiar with TensorFlow, I apologize for that. Next, I'm moving the logits to CPU because again, I want to keep track of the predictions and the true labels. So again, this is where I keep track of the average loss and the predictions labels with the true labels. So then later I can do some metrics on that. Okay, so the validation function, just like I mentioned before, it's just used to evaluate the model. So it's gonna output just the predictions. It's fairly similar to the train function, but again, you got to set your model that you got to set into evaluation mode. So this way, you're not doing the back propagation and all of those computings. Again, you got to iterate for each batch in the data set. Again, I'm keeping track of the true labels because later on I want to see how well are the predictions compared to the true labels. Again, I have to move the batch to device, so again, similar code. Next, when I do with torch.noGradient, a lot of you that know Pytorch are really familiar with this. Is basically I'm saying, hey, do not store the gradients. I'm not doing back propagation. I just want to get the predictions. Again, we're doing forward pass. I'm grabbing the logits, which are basically the probabilities. And then I'm moving those to CPU and converting them to NumPy and just getting my predictions from those logits. And again, I'm keeping track of the loss and the predictions. So then I can have like an average epoch loss and so on. So basically the train and the validation functions, they run on a single epoch. So if you go here, it says for batch and data loss. So it basically just does it for one epoch. I also mentioned it here. Okay, so this was just the helper functions. I know it's a lot to digest. One thing that I want to mention is the helper functions. You'll see that you can use the train and validation in other Pytorch, in other transformer models. So they're really reusable. Like I'm using the same train and validation for Bert, like the same code. So I made it so it's really highly reusable. And plus, if you use it before and say, hey, this guy already cleaned up the code and everything, made it a function, yeah, I can just copy paste that function and use it, right? So feel free to do that. That's what I'm doing. I build this for myself, and also I want to share with others, and if it helps, great. Next, so looking at our table of contents, load model and tokenizer. So we're going to load 3 essential parts of GPT-2, right? We need to have the configuration, the tokenizer, and the model. So this is kind of some details that I got from the Hugging Face documentation. You can go through it. This is like more greater detail of like specific functions that I'm using here. And again, I also mentioned that Hugging Face did most of the work for us, so it's really easy and straightforward to use their code. And actually, they're the ones that did the code for the classification layer. So I didn't have to implement this GPT-2 classification from scratch. I'm just using their implementation. They already implemented this for us. So Hugging Face is doing a great job at this. One thing that I want to mention is with classification is remember that I showed you that you have to use the last token embedding, and you're probably familiar with padding, that you have to do padding in your text, so all of your examples have the same length. And when you do padding, obviously you don't want to grab the embedding of the padding, right? Because that's just a 0. You want to grab the embedding of the last token. So that's where I talk a little bit more details into what they're doing, what Hugging Face did here. So they made sure we're not using the padding token, we're using the actual last word token. So that's really important. Okay, so all right, so like I mentioned, we need to get the model configuration. Again, we're calling GPT2 config from pre-trained, so this is pretty standard for Hugging Face if you're familiar with it. This is where we load the configuration. So the configuration might be, hey, how many decoder blocks does this model have? What's the embedding size? What's the maximum input size? So all those parameters that you need to define the GPT-2 model. So next is a tokenizer. So again, like I mentioned before, it needs to have its own tokenizer where it basically knows, okay, what is the vocabulary that GPT-2 was previously trained on. And since we're using a pre-trained model, then that's why I'm calling from pre-trained, because this is a model that already seen millions and millions of text documents and already has those embeddings trained for us. So that means the tokenizer knows, okay, which words the GPT-2 previously seen in its pre-training and knows how to handle new text data. Again, I also need to do padding side left. So that means where you have, so you want to have all your text sequences have the same length. And obviously there'll be movie reviews, a lot of them that don't have the same length, right? Because people express themselves differently. I might express myself in one sentence, other people need 2 or 3 sentences, and so on. So the text sequence varies a lot. So we need to pad those. So we need to make all of them the same length. So remember in my imports where I used, I had my max sequence length of 60. So what I'm saying is that, okay, I'm just going to use the first 60 words. If there are texts or I guess movie reviews that have less than 60 words, I'm just going to do padding on the left side. So let me do it like this. So I have my text sequence is less than 60, let's say it's 50. So I'm going to put some padding here, so put zeros, and then so put 10 zeros, right? And then the rest 50 words. So I have a sequence of 60. And when I mean padding at the left, that means I'm putting zeros at the left side of the sequence. So I hope that kind of makes sense. If you're familiar with padding, then I'm sure you probably understand that more than I do. So again, I need to pad on the left. So that means the last token that, remember the embedding of the last token, it's actually on the far right. So actually, let me do it like this. So the last token, the last embedding of the last token, it's going to be on the far right. And then all the padding is going to be on the left side. That's the reason why we're doing left padding. Obviously, we also have to define padding, since GPT-2 is not familiar with padding. And looking at a tokenizer, we're just going to use the end of sequence, which is called a EOS token. And in our case, it's 50,256. So, and I got one quick question on this in the chat. So why padding on the left as opposed to the right? It's because, so like I mentioned, we're using the last embedding in our sequence, right? And our last embedding in our sequence is on the far right, right? And if you want to get the far right embedding, if you want to pad, it's better to pad on the left side. Let's see if I can. So you easily pad on the left side. So that is the reason why we're padding on the left side, because GPT-2 is looking at the right side. Okay. And again, if I see a question that's really straightforward related to what I'm talking that moment, I'm actually just going to answer it. But I'm going to follow up with the rest of the questions, so bear with me. Okay, so this was with the padding side. I know it's probably a little confusing. I hope that cleared it. Next, we have to load the actual model, right? So we have GPT-2 for sequence classification. Again, this is our GPT-2 model that has a sequence classification. Can you guys, I guess, stop like writing on it? Okay. So again, this is GPU for sequence classification. So it basically means that it's the GPT-2 model that has a sequence classification layer on top of it. So remember the inner workings part, like the last layer, this is what this is. And Hugging Face did it for us. It's already built in for us. So I'm loading the model. Next, what I call a resize model embedding to match the new tokenizer. So this is basically saying, hey, the original vocabulary for the model is 50,000. If I added any extra tokens, what is the new vocabulary size? In this case, I'm adding the padding vocabulary. So that means I added a new token in my vocabulary. Oh, actually, sorry, I actually did not add anything. Sorry, I take that back. I did not add any new tokens because I'm using the end of sequence token that's already in the vocabulary. So the resize model embedding to match new tokenizer, and this code, it's not going to do anything basically, because the vocabulary size and the model are the same. But it's a good practice to do it anyway. And in case if you want to add words to the vocabulary, this is where you really need to run this line of code. So you're basically resizing the basically how many words does GPT-2 can recognize. What's the vocabulary, right? I hope that's clear. This is where I fix the model padding token ID. So basically, this is where I need to configure the end of sequence token. So this is kind of the extra, these are like extra steps for the padding process. So I can do the text classification. Next, gonna load the model to device, right? So if you're familiar with Pytorch, this is straightforward. You just load it to GPU or CPU or whatever resources you have available. All right, so I covered the load model and tokenizer part. So again, it's on the table of content. Now let's go into the data set and collider. So that is where I'm basically loading the dataset class and using the collider to basically create my Pytorch dataset. So this is where I use the movie review dataset class, to create the Pytorch dataset. And guys, I'm just like reading from this. Everything is documented here. So if whatever I'm saying here, it's already there written. So you can look at it later. Again, since we need to input numbers, to our model, we need to convert text and labels to numbers. So that is the purpose of the collider. So it takes data that's outputted by our Pytorch dataset, and that gets passed through the data collider, and then it outputs the sequence that can go straight to our model. So I also mentioned here that I keep the tokenizer away from my Pytorch dataset. So some of you that are familiar with the Pytorch and Pytorch dataset, I could have skipped the collider and just embed the code into the Pytorch dataset. But I like to have my code more modular, so it just makes the whole code cleaner and like better structured, and you can reuse it later in other projects a lot easier. And again, as with always, any experiments, I strongly recommend to use a validation text file in order to determine how much training is needed to avoid overfitting. So don't try to use your test data right when you're fine tuning or when you're trying to decide, what parameters you use for a model. Test data, you're only going to use it the last part where you already have the model, you already know what parameters you're going to use. So again, after you figure out what parameters yield the best results, then the validation file can be incorporated into the train and run a final train. So what I just mentioned here is basically good practice as a data scientist, as a machine learning or whatever you're doing. It's just common sense, right? You have your train data and your validation that you use to do your experiments. And once you have set your parameters, then you combine train and validation, run a final train, and then you evaluate your model on the test data. And again, like I mentioned before, the collator that I used to format the Pytorch dataset, it basically outputs a matching input that's needed for GPT-2. So remember the token IDs and everything. It matches the sequence that that GPT-2 needs as an input. Okay, this is where I create the data collator, where I use the tokenizer, label IDs, and where I specify the maximum length. So remember that I said I'm just going to use the first 60 words. So that's where I use max length. Okay, this is where I deal with training. And I mean with the training data. So this is where I create the training data set. Again, my data set, it's already split into files. So I have, if I look at my Jupyter notebook, if I look at the data set, see I already have train and test here. So I already have them split physically. So I'm not doing a split here on the fly. It's already being done. That's how the data set came. So I'm specifying the path to the train data set. This is where I create the Pytorch data set, and then this is where I have the data loader, which is the ones that batches the data. That is why I have the batch size here as a parameter. And this is also where I use the collator, where I specify the collator. So the data loader basically takes the data set and puts it in batches and transforms the text into IDs and just makes the whole input available to the model. So then we can feed it to the model. I do shuffle through since it's going to shuffle the examples after each epoch. That's also good practice when you're training the model, right? Next, dealing with the validation, same exact process. Again, I'm reading from the test data. I did not have a separate validation set, so I'm actually using the test as a validation, which I know is terribly wrong. Don't do that. This is just for tutorial purposes. And to be honest, I was kind of lazy to do it. And see here, for the validation data, you want to have shuffle equals to false. So that's one important aspect I want to mention, is that when you validate or when you're doing validation or testing, you don't want to shuffle the data, right? Okay, so if we go back to our table of content, so I just finished covering the data set and collator. And now we can go ahead and start training the model, right? Like I mentioned, with any Pytorch model, created the optimizer and schedule used by Pytorch training. So I use most common parameters for transformer models. Again, feel free to try other parameters. If you're asking me why am I using these parameters, to be honest, they kind of work okay, and that's what I've seen other people do. So I know it's a lame answer, but it's just what it is. And in the train code here, basically I'm just looping through the number of defined epochs and just call the train and validation function. So remember, the train basically does one pass through the whole data. So it does one epoch. So I'm just calling it for each epoch. Same with validation function. I'm trying to output. So I'm looking here. I'm trying to output in the training process to output the information, kind of similar to Keras. We have the train loss, val loss, train accuracy, validation accuracy. So those of you who also use TensorFlow, you might see that familiar. After training, obviously you want to plot the training validation loss and accuracy curves so we can see how well the training went. And also one note I want to make here, I'm going to reiterate over it later. The training plots in this tutorial are going to look weird in a sense that validation accuracy starts higher than the training accuracy. So don't think of these plots as, hey, that's what I should know. They're actually not right, and they're not correct. And the reason for that is that I'm not showing you how to get best performance here. I'm just showing you how to use it for text classification. So I'm defining optimizer, which is our atom optimizer. W stands for weight decay. We have our learning rate. So default is 5e minus 5, so 5 to the power minus 5. I'm using 2e minus 5. You can use different learning rates. The epsilon, I'm using 1e minus 8. Again, you can change that if you want. These are just numbers that I've seen a lot of people use often. Total number of training steps. So that means how many training steps am I going to do? So that means is, okay, how many epochs do I have times, how many batches do I have? And the total steps is basically parameters that we need to provide to our scheduler. So then the schedulers know how fast should it decay the learning rate, depending on how many training steps we have. Warm-up steps are 0. We keep track of all the loss and accuracy here. Next, we look for each epoch, right? So I believe I put 4 epochs. So for the first run, first epoch, I'm grabbing my train labels, train prediction, and train loss, calling the train function. So this is where I'm calling the train function, and it does one pass the data, and then it outputs the labels, the train labels, and the predictions, and also the loss, and it also trained the model for that epoch. Next, I want to compute the accuracy, right? So along the training, I want to see how accurate is the training. Next, I want to get the predictions for the model on the validation data. So this is where I'm calling the validation function, right, on the validation data. And then I'm just plotting basically after each epoch, I'm just plotting the basically the loss, the accuracy on both train and validation. And also want to store all this so then I can plot it later. And this is where I plot the loss curves and also plot the accuracy curves. So let's look at some numbers here. You can see after each epoch, it shows the train loss, the validation loss, the train accuracy, and validation accuracy. And usually when you fine tune your model, you want to keep looking at these and say, okay, is the training loss going down? That means you're doing something right. If it goes higher, then definitely something's wrong. Same thing with the validation, right? If the validation goes lower, that's fine. If it starts getting higher, it means, hey, my model starts overfitting. So kind of gives you a live feedback, for what's happening with your model. Instead of just training it and wait one day and then the next day you come in and say, oh yeah, it's not doing well. You can see in real time that maybe after 1 or 2 epochs, it's clear enough to see that, hey, the model is not going in the right direction, and you can just stop it. So that's just how I work. I like to see them in real time, see if, how well the model is doing in real time. Let me go over the plots. So this is the train loss and the validation loss. The train loss is in, I guess, red, orange, and the validation loss, it's in dashed blue. So you can see that, hey, the train loss started really high, starts going down, which is good. But then the validation loss, it started lower than the training loss. And it went down for a while, but then it started to go back up. So and that means we see that around epoch 2, it's where the training and validation starts drifting apart. So maybe that's an indicator of, hey, maybe the model is overfitting, right? And you might wonder, is like, why is the loss starting lower than the training, right? Isn't the training should be lower than the loss? And the answer is yes, you're completely right. And the reason for that is that, uh, I guess it's just the way that I have the train and test split. They're really big. They're 25,000 train and 25,000 test. And I didn't split the data well. So it's just coincidence, I guess, that just happened to be that way. Next, if you look at the accuracy, again, kind of the same behavior. The validation accuracy started higher, which I guess that should be the case for training, right? Because validation is data that the model never seen. And you can see the training accuracy keeps going up. That's good. But the validation accuracy starts lowering or stagnating, which is an indicator that maybe the model is overfitting, or maybe you can stop training after 2 epochs. Again, want to repeat myself, these plots are not normal behavior. Um, I'm not trying to get the best performance here on the sentiment data. I'm just kind of showing you how to do it, and then what to look for when you're using your own data. So that's it on the train side on our table of content. Uh, Finally, so we're getting close to finish here. The evaluate step. So when dealing with classification, it's really useful to look at precision, recall, and F1 score. I'm sure all of you, a lot of you know or use these metrics. Um, these are like good gauge to have when evaluating a model, right? And also to look at the confusion matrix, right? That also tells you how what is what classes is the model having trouble predicting, right? Um, so this is, again, I'm using the validation function that I showed in the helper functions to run again through the test data, get the predictions. Then I'm just outputting a classification report. And here we can see the positive and negative. We can see the precision and recall. And we can clearly see, so we have our precision, negative and positive. See that 82, 84. And then the macro average is 83. Recall is 84 and 82. Again, the average is 83. F1 score, which is a combination of precision and recall, 83 everywhere. And then support is basically how many examples of that label you have. So we have 12,500 negative examples and 12,500 positive examples in our test data. And like I mentioned before, it's good practice to show the confusion matrix. So this is our confusion matrix for GPT-2 fine-tuned model. It's normalized, so it's only values between 0 and 1. So we see that is doing pretty well. I mean, it's not doing perfectly or great. I say these are decent results. Probably doing more tweaking, you can get better results. I think if you use BERT, you might get slightly higher results. But again, this is not, so I'm not saying that GPT-2, you should use only GPT-2 for text classification. No, I'm not saying that. I'm saying, hey, this is, if you're doing text classification and you're trying to run multiple models or multiple experiments, hey, do you know that GPT-2 is also an option for text classification? So that is the purpose of this tutorial, like this code in today's tutorial. Kind of give you that option saying, hey, my text data, maybe the text data that you're using is not well suited for BERT. It might be better suited for GPT-2, and GPT-2 might give you better results than BERT. So again, it's just something that you can try. It's an extra, I guess, I would say it's extra tool that you can add to your tool set when doing text classification. So that's it in this notebook. So regarding the coding session, I just ran this a few minutes ago and it works. Again, if you're having problems or something, shoot me an email or let me know. If you made it this far, you know, in the coding session at least, congratulations. It's like a ton of information here. I know it can be really hard to follow, and I really appreciate you guys, your patience. So this is kind of all I hope I covered enough of the code. If there are parts of the code that you want me to go over it again, or they're not clear, please ask in the chat or email me offline. I'll be more than happy to kind of give you. So let's go back to the slides now. So basically, this concluded our coding session part. Next, I want to go over some conclusions. But before we do that, let me give you another link. Sorry to keep you guys making you work here. So I just pasted in the chat a link to another poll that I hope you guys can take. This is basically providing feedback for me for this tutorial, for this presentation. And they're basically 4 short questions. You can answer them, you know, as detailed as you want. And I really appreciate that. So you guys are guiding this tutorial, and that's why it's really important that you guys fill your information in those polls, and it's great feedback for me. And if something I can improve on, or something didn't went well, or something did went well, again, please don't hesitate and follow the link I just provided. All right, so just a few conclusions I want to put out here. So basically, what we did today is I showed you that GPT-2 can be used for text classification. You know, is it the best solution? You know, probably not. This is not. It's not going to guarantee state of the art or like best results in your text classification task. Depending on the data and the classification task, you know, GPT-2 could outperform, you know, other transformer models. And again, like I mentioned, it's always good to have options, right? So when you're doing research, or maybe you're at a company and you're doing text classification, you have to classify some text or structure some text. Say, hey, BERT is just not good enough. Hey, try GPT-2, right? Now you know how to do it. Maybe it'll give you good results. Maybe it'll give you similar results, but it's more robust. So it's just a tool that you can add to your tool set. So again, I want to emphasize on this. I'm not saying only use GPT-2 or don't expect GPT-2 to give you the best results. I'm just saying, you know, it's an option. So Thank you so much for joining in. These are my contacts, and let's stay in touch, right? So um, again, with AI Camp, if you want to reach out to me personally, this is my website, LinkedIn, Medium. All this material is available. And before I close, I want to go back through some of the questions and kind of answer them. So if you want to hear more or you want to hear a question answered, please still continue to stay here. If not, I really appreciate you guys spending the time here. And then please don't forget to give me a feedback there. Um, and let me go back to some of the questions.
Great. I just want to quick put note. Please post your questions in the chat. We still have some times, and if you prefer to speak to ask questions, just raise your hand, or you can just, you can unmute yourself. I will enable the unmute, so you can just, feel free to speak to ask questions.
Great, thank you, Bill. Yes. Let me try. Let me actually show this to you guys so you kind of see what questions am I looking at. Let me start here. So what will be the output, positive, negative of the following text? Nice, nice, good, good, happy, happy, great, positive, positive. This is really bad movie. So that's actually a great question. I strongly recommend you guys try that. To be honest, I don't know what would be the answer. I know usually transformer models and GPT-2 and Bert, they're really robust on this kind of things. So they rely on the context a lot. So even if you have those positive, no words, and at the end you have this is a really bad movie, maybe it knows to focus. Hey, this was really a bad movie. So yeah, I encourage you to try that. And same question. Do we need to have access to GPT-2? The answer is no. GPT-3 is the one that you need access to because it's a really huge model. For GPT-2 and everything that I showed you today, you can just click on the notebook that I gave you in Colab and just run it there. You don't need any access, anything, just one click and that's it. Could we tune batch size in the base? Yes, you can do that. Okay. It is productive to add a third label of neutral. The answer is it could be. The problem is that I'm doing supervised training here. So I had labels for negative and positive. So in order for me to do training on neutral data that I don't have any labels for neutral, I mean, in this case, it's not going to work, obviously. But if you have data that has the neutral label, yes, that will work. Will this work on Kaggle? Yes, absolutely. Can you do some more explaining here with GPT-3 instead of GPT-2? One thing I can say is that GPT-3 is just way larger than GPT-2. It has a lot more decoder stacks. It has the embedding size. It's a lot bigger. So that's one thing I can add to that. What do you prefer, Pytorch? What do you prefer on Pytorch frameworks? Raw Pytorch versus Ignite versus Light? That's a good question. So the reason why a lot of you that use a lot of you that use Ignite or Lightning, you probably seen like, hey, this guy could have cut down to like 3 lines of code instead of writing 100. I agree, those are really great tools. When you work in research, I mean, like I'm doing, your advisor might say, hey, the fourth layer, the third layer from the fourth block in the decoder, can you change that 2 to a 3? So when your advisor gives you that specific detail, then you cannot just use Lightning or other like frameworks that just wraps around it. You need the raw Pytorch code so you can go in and change that. So the reason why I'm using raw, because in the long run, it's easier for me to do research with, because I can do crazy complex changes to the model and to the code. So I hope that answered. Um, GPT-2 is available on TensorFlow too. Yes, it is. And I think also Hugging Face, yes. Also with the Hugging Face library, they have support for TensorFlow. How does GPT-2 compare against GPT-3 in terms of efficiency? I would say GPT-3 is not efficient at all, obviously, since they need hundreds of GPUs to run it. I think you can go a long way with GPT-2, or depending on your data, you can go a long way with just maybe basic machine learning models. Does it have any data limitation for algorithms to work with? I would say the only limitation, like I mentioned previously, are the sequence length. So how big of a sequence length can you feed to the model? Like you have the small, the medium, and the extra large GPT-2 version. So those are kind of limitations. White padding on the left, I already covered that. Will the last embedding always predict the same word then? Actually, I tried it, and you should be able to predict the same word, especially if you're doing this, if you set the seed fixed. So you should be able to predict the same words, yes. Have you tried 3 classes, positive, neutral, negative? So like I mentioned before, I did not try that since the data set does not have a neutral label. Okay. TensorBoard is available in Pytorch. Yes. Yeah. Again, guys, like the code that I wrote is not perfect. It's just the way that I do research, and I just try my best to document it enough so you kind of follow along what's happening. But there's a way better ways to code what I just did. Okay. Can you comment on the difference between GPT-2 and GPT-3? I already mentioned basically they just scaled up GPT-2 for GPT-3. You also output a confidence score using a softmax for each class. Have you tried to put a third class? Yes, you can do the confidence scores. So instead of doing an argmax and picking up the highest predicting, you can just look at the probabilities and just say what is the confidence of each class. Okay. Could you please comment any other transformer? If you're referring, if you could use any other transformer models, then yes. So like in the code that I mentioned, I have GPT-2. You can use different size of GPT-2. And obviously you can use Bert or any other types of transformer models. Oftentimes, training metrics will be worse than validation metrics if dropout or lossy arguments are used. I missed the portion precision, so I wasn't sure if that was the case. Do you think that might be what happened to your model? That's a really good question and like a good observation. Often training metric will be worse than validation. So on that, yeah, it just depends on it, and it depends on the data set you have, how the data set looks like, how the training data set looks like, and how the validation looks like, and also the parameters you use. So I cannot give like a clear answer that it depends. On the recordings, I think Bill will mention that. I think that there are recordings on that. Okay. Okay, if you get an error on the Colab, like plotting training curves, I just realized that this morning. What you can do is basically just rerun the Colab again, and it will work. Okay. Yes, again, if you're getting that error, just rerun the code again, and that should work. Yeah, for some people, it worked fine the first time. If not, just rerun it, and then that should fix the problem. Okay. To improve classification performance, can I add deep learning neural networks upon GPT-2? You can do that. To be honest, I don't think it'll make a big difference. You already have so many layers in your GPT-2, and GPT-2 is already doing such a good job that you're just overly complicating things. You can do that if you want. I wouldn't add too many layers. It already has enough. So that's my take on that. I think, could we tune the pre-trained model for other purposes? Yes. So you can train it for other classification tasks, depending on what labels do you have or labels you try and predict. Yeah, you can definitely do that. Like, we tune the parameter, like what parameters or layers. So yeah, if you want to do regression, for example, you can clearly do that with the exact code that I just mentioned you. It just with regression, you only have to specify the number of labels as being one because you're only predicting one number. And if you're doing classification, you can just replace whatever the number of classes you have in your data set. And those are kind of the only changes you need to make. Yeah, no problem. C125. Yeah, again, guys, if you're still around, if you can give like a feedback, I just pasted the link again. Just give a feedback, what I can improve or what went good or anything.